All right, guys, homework 6.5. Remember, some periods had to do the consolidation activity for this as well. If you have to do the consolidation activity, do the best that you can. The rest of us, we're going to do homework 6.5. So write your name on it. And write your period number. All right, so use the function rules from the Roses project to answer the following questions. In each rule, x represents the number of roses ordered, and f of x represents the cost of the order. So let's pull that out for just a second. F of x is the cost of the order, or the total bill. X represents the number of roses. So this guy represents the number of roses. Okay, so the total bill at Roses Are Red is going to be $20 plus 75 cents times the number of roses that you order. If the soccer team orders 100 roses from Roses Are Red, they will pay. Well, let's see. F of x is my bill, $20 plus 75 cents per rose. Well, they're ordering 120 roses. So you want to do 20 plus, am I right? Remember, that's right, you've got to do 0.75 times 20 first. So in your calculator, you're going to hit 0.75 times 120, and you'll get 90. Bring down the rest of your whole thing. Now 20 plus 90 equals 110. And we're done. Now we need to just make sure and clean it up. F of x, which is the total bill, is $110. Make sure you have the dollars there. So they'll pay $110. If they order the same amount from Flower Power, well, so we have to change this up a little bit. Flower Power, the total bill, F of x, equals 60 plus 50 cents times the number of roses, which is 120. So if we do this, do in your calculator, 0.5 times 120 is 60. 60 plus 60 equals 120. So f of x, my total bill, is equal to $120. So obviously you want to use Roses Are Red if you're going to only buy 120 roses. From Roses Are Red, the soccer team can get blank roses for $95. Well, I'm going to give myself a little bit more room here and do a little bit, do a little bit on a piece of paper here. So for number 3, Roses Are Red. The function looks like this. So from Roses Are Red, the soccer team can get blank roses. So I'm looking for that guy, which means I've got to replace this with something. Remember, f of x is the total bill. Well, our total bill can be $95. So I'm going to replace the total bill, f of x, with 95 and rewrite the rest. Well, now look what we've set up. We've set up a solving situation. We want to know what x is by itself, so we need to undo PEMDAS. PEMDAS has already happened to this. So let's talk about PEMDAS, how it's happened to x. So PEMDAS PEMDAS says that x gets multiplied by 0.75 and then added to 20. Well, let's break that up and let's show the opposite. If I go the opposite way, that means I'm going to subtract 20. The opposite of multiplication is division, so I'm going to divide by 0.75. From the bottom up is what we need to do to both sides of this equation. So we need to subtract 20 from both sides. Bring down your equal sign. 95 minus 20 is 75. 20, positive 20 minus 20 is gone. Bring down your positive 0.75x. So we subtracted 20. Now we've got to divide by 0.75. So divide both sides by 0.75. 0.75 divided by 0.75 is 1x. 75 divided by 0.75 goes on the bottom. 75 divided by 0.75, 75 divided by 0.75 equals 100 roses. Now remember, X is the number of roses, and so that's how I knew that it's not $100, it's 100 roses, because my X this whole time has represented the number of roses. So from Roses Are Red, you can get 100 roses for $95. All right, let's do the same from Flower Power. So they want to know, Flower Power, the equation is f of x equals $60 plus 0.50x. We want to know the soccer team can get blank roses, so I'm looking for that guy for $95. So my total bill, f of x, can be my total bill, can be $95. So rewrite the rest. Now again, look what we've done. We've set up a situation where we need to get x by itself. So let's talk about what happened, or PEMDAS, PEMDAS has already happened to x. Let's see what's already happened to x. Well, first we got multiplied by 0.50. Then, once it got multiplied by 0.50, it got added to 60. So break that up, and let's write it backwards. Opposite of plus 60 is minus 60. Opposite of multiplying by 0.5 is dividing by 0.5. So that's what we need to do in order from bottom to top to this side. So we're going to subtract 60 from both sides first. 95 minus 60 gives me 35. 60 minus 60 is 0. And we bring down our positive 0.50x. So we subtracted 60. Now we have to divide by 0.5. So divide by 0.50, divide by 0.50. 0.50 divided by 0.50 gives you 1x. 35 divided by 0.5 should give you double, which is 70. Now, ask yourself, is this $70 or 70 roses? Well, x is the number of roses, and so this is 70 roses. So, at Roses Are Red, I can get 100 roses for $95. At Flower Power, I can only get 70 roses for $95. So obviously, you'd go with Roses Are Red. So now we need to apply what we've learned about function notation to answer these questions. Show your work on your paper. Okay, well, easy enough. Here, I'm going to show my work on here. So we're going to start with f of x equals 2x. So this is our parent function, they call it, the original function for A, B, C, D, E, and F. So here's what we need to do. For A, it says f of x is equal to 6. Remember, if they write it in there, they want you to replace the x over here. So they're saying plug in 6 for x. Well, we can do that. So here's A. So we're going to say, hey, audience, we're going to plug in 6, and we're going to get 2 times 6, because the x is now 6. You leave this side completely alone. It's going to keep looking like that forever. 2 times 6 is 12. So f of 6 equals 12, which tells my audience if I put a 6 into this machine, I get a 12 out. So f of 6 equals 12. Let's try it again for B. You start with your original function, f of x equals 2x. They want to know, what is it like when you plug in negative 11? Well, we're going to plug in negative 11. So, hey, audience, we're putting a negative 11 into this machine. So you have 2. X is negative 11. 2 times negative 11 is negative 22. So when I put a negative 11 into my machine, out comes a 22. So f of negative 11 equals negative 22. Now we've got to take that same function again, f of x, and we've got to plug in 2.75 for x. So we're going to plug in 2.75 for x. Well, 2 times 2.75, so 2 times 2.75 gives you 5.5. So 5.5 is what comes out of this machine when I put in 2.75. So if I put in a 2.75, I get out a 5.5. All right, let's try D. Take your original equation, f of x equals 2x, which is the one up here. Now they want to know f of x equals 20. So this is now equal to 20. So if I replace that with 20, they want to know, well, what's x? Okay, well, we've set it up that we need to get the x by itself. Well, right now, the x is being multiplied by 2. We have to undo PEMDAS. So divide by 2, you get 1x is equal to 20 divided by 2, which is 10. So if f of x is 20, if this side is 20, then x is equal to 10. All right, let's try again. Original function is f of x equals 2x. They're saying the f of x part, this side of the equation, is equal to negative 14. Well, when f of x is negative 14, so I'm going to put in negative 14, what does x equal? We're going to divide by 2, divide by 2. 2 divided by 2 is 1x. Negative 14 divided by 2 is negative 7. So x is equal to negative 7. All right, one more time. So we've got f of x equals 2x. You always start by writing your original function, which is over here. Now, they want f of x, they want this whole thing to equal 29. So replace it with 29 and rewrite the rest of it. So we've replaced the f of x part with 29. So now all we've got to do is answer, well, what did x equal to begin with? Well, let's see. If x is being held together with the 2 by multiplication, all we've got to do is divide them to break them apart. So 2x divided by 2 gives you 1x, because 2 divided by 2 is 1, not 0. Remember that. 29 divided by 2, well, let's see. It's not an even number, so we know we're going to get a 0.5. So that gives us 14.5. So if they want the function of x, the entire thing over here, to equal 29, that means they have to put in a 14.5. So let's take a quick look at this. This one told us to put in an 11 and get out a negative 22. This is giving us the input, and we've got to tell them the output. This second row, D, E, and F, told us what the output is, and we had to tell them what went into this machine. So they said, well, listen, a 20 came out of my machine here. What did I put in? All right, so try the rest on your own.